linear functions are just functions that have got straight lines in them, and not all linear functions are nice and direct like the ones with straight lines that go up in a constant way. Here's an example of what we call a step graph. Now, the important thing to remember about a step graph is you'll notice that some of the lines start with an open circle and finish with a closed circle. And what that means is if there's an open circle, that particular point is not included in the measurement. And if it's closed or coloured in, then it is included in the measurement. Now that's the key thing to remember when we do this. So if you look at this graph here, the hours parked 6, is not included at this level. It's included at this level. And so what you've got here, if you look at it, is parking fees, and as time goes by, the fees jump up. So for the first 3 hours, it's obviously free, and then for the next 2 hours, for the next 1 hour, it goes up, and then it continues to go up in jumps rather than in a nice linear function. So let's have a look at how these work. First of all, it says find the cost of parking for 2.5 hours. Well, 2.5 hours would drop this into here. So we'll put here that would be $0. Now for 3 hours, you'll notice the cost here is also 0 because the 3 is included at this level. So that would be $0. But for 3.5 hours, it drops up into this section here. And these are going up in 2s, so that would be $6. 5 hours, that includes this one. So for 5 hours parking, we're looking at $10. And if we go 5 hours, just over 5 hours by a few minutes or even just a minute, it takes you to the next level. So that would take you right up to $14. So you can see that these are called step graphs because of the jump up in the reading of these things. All right, so it says, what is the maximum time a car can park for $18? Now, these are very important things to read. That's 18. Let's go back to 10, first of all. The maximum time. If we go to the 10 level, that's here, they can go right up to here for our $10. So we could park for 5 hours exactly for $10. And for $14, that takes us up here. We could park for 6 hours. And of course, for $18, we could go right up to 10 hours. Now it says, what is the range in time which a car can park for a cost of $0? Well, the range in time would be, for this one, 0 to 3 hours. And for $18, well, it would be more than 6 hours. So anything more than 6 hours, there's your $18, and there's 6 hours, but it'd have to be greater than, so more than 6 hours. And then, of course, up to and including 10 hours. These are important words to use when you're using these sorts of examples. More than 6 hours rather than 6 hours, because of course you couldn't include the 6 hours there. So you've got to be very careful when you use wording to make sure that you're actually clearly describing what these are. Let's have a look at one more. $6 is here. Well, it would be more than 3 hours. So we'll write that down here for number 3. I'll write this over here. So it would be more than 3 hours. And let's see, for $6, we could go up to here, so including, so it's up to and including 4 hours. So there's our step graph. Quite easy to read. You've just got to be careful that you use the open circles and the closed circles correctly. Right, here's a line graph, but you'll notice that the gradient changes along. Even though it's joined together, it's not a constant gradient. So we call this a piecewise linear function. And the explanation is here. It means that it is made up of several joined straight lines, and each part of it has a slightly different gradient. So not only one straight line. And a good example of this are tax rates. So that as you go up with your income, the amount of tax or the tax rate that you pay increases as you go along. So let's have a look and see what we can read from this. The first question is, find the tax payable on $40,000. Well, let's have a look. There's our taxable income, and this is the tax payable. So to find the tax payable on $40,000, you actually, I'll take an arrowed line again here. So let me just take this line here. Okay, so we're going to go from $40,000 up to the line, and then we're going to take the 40,000 across to here. Now, once again, it's very hard to read these graphs, but I'll give you the information. In this case, I'll write it down here that the tax payable is $4,200. I'm sorry, look, the tax payable is $12,000. That's the first thing we need to write down. $12,000 on $40,000. Now, we'll look at the rate in a minute. That's what I was having a look at to start with, but you can just read off the tax payable as $12,000. Going the other way, we've got the income that pays a tax of $20,000. So we're going to go the other way. So take a line again, go from 20,000 along to the graph and down again. So if we look at that, it's somewhere just under $60,000 that our income would have to be in order to pay $20,000 in tax. Turns out to be $59,000 worth of income in order to pay a tax of $20,000. Now this is the part where you can work out the gradient. It says find the gradient of the section between 30,000 and 40,000. So that's this distance from here, 30,000 to 40,000. Well, the gradient would be equal to the rise over the run. Now the run part of it is the distance, that's $10,000. So we can put our $10,000 here. And we can just read that off the information because it's between 30 and 40,000. And the question is, for that 30 to 40,000, which is that distance along here, how far up does it go? And it's pretty hard to read this off, but it actually goes up $3,600. So that's $10,000. So every $10,000 along, you pay $3,600 tax, which gives you a gradient of 0.36, or another way of saying this is 36 cents in the dollar of tax. So 36% tax in this case. So we can write that down as well. So anything between $30,000 and $40,000, you pay 36% of that in tax. And let's have a look at one last one to show the variation in the gradient. It says find the gradient of the section between taxable income 60 and 70,000. Now you'd expect the tax rate to be higher, and in fact it is. So we'll put our gradient here. We're going to have exactly the same distance of $10,000. So we're looking between $30,000 and $40,000. Between $60,000 and $70,000. So that's 60 and 70 is here. So we're looking at the rise along here. You can read that off, and it turns out that you actually have a rise of $4,200. So what does this mean? Well, it means a number of things. First of all, the number is 0.42. Translating this percentage, you pay 42% tax, which means 42 cents in every dollar goes into tax. So you can see the gradient gets steeper as you go up. indicating that the tax rate increases as your income goes up.